Welcome to the second video in the series, Do the Integrals in Your Head. So for these 10 integrals, we actually have to take a small u-sub for each of them, but the u-sub is actually not so bad. Take a look at the first one. We have to integrate sine of 3x minus 2. The choice for u will just be the inside, and when we differentiate that, we get just a 3. And whenever we have that, that's going to be so wonderful. Whenever the derivative of the u is just a number, this is just so wonderful. And that's the same for all the cases right here. Well, we just have to go ahead and ask ourselves, how do we integrate sine u? And the answer for that is negative cosine u, and the u is just the input, which is 3x minus 2. But the derivative of this right here is a 3, and we have to do the antiderivative for this indefinite integral. So we divide it by the 3. So I'm going to put down a 1 over 3 right here. That's it. And then of course put on the plus c. That's it for the first one. However, if we had 3x squared minus 2, then we cannot do this. Do not just divide it by 6x. We can only do this when the derivative of the u is just a number, just like that. Alright, now please pause the video and try the rest of the questions before you watch the solution. Ready? Okay, next one. Well, here we have 3 minus x to the first power on the bottom. That would be a natural log situation because it's just a u, right, to the first power. Alright, so we will just get ln absolute value, and the input is 3 minus x. But the derivative of 3x minus x is a 1. It's just a negative 1. So we will have to divide it by negative 1. So I'll put down the negative right here. That will do it. Put down a plus c. Again, we divide it by negative 1. So it's the same as multiply by negative. Continue. Next. U will be this, and the derivative for that is just pi, is just a number. Integrate cosine, we get sine, and then we keep the input, which is pi x. The derivative of this is pi, so go ahead and divide it by that, which we multiply by 1 over pi, and then put on the plus c. That will do it. Continue. This one. This is 2x, this is also 2x. That's good, because that will be the choice for u, which that will give us the derivative being 2. So integrate secant u, tangent u, we get just secant of u, which is the 2x, and we divide it by 2. So multiply by 1/2, and then put down plus c. That will do it. And we need to be able to do this in Cal 2, because if you want to show all the u-substitution steps every time, Calculus 2 will be impossible to finish because it has a lot of steps. So these are the ones that you really have to know how to do in your head. Now let's continue. Number 5, e to the 1/2 x. Okay, we have e to the 1/2 x. The derivative of 1/2 x is 1/2. Divided by 1/2, it's the same as multiply by 2 over 1. So we multiply by 2, and then plus c. Done deal. Continue. This. Again, the bottom is just 1 plus 4x to the first power. So that will give us natural log of the bottom, which is 1 plus 4x. And we put this in the absolute value. But the derivative of 1 plus 4x is a 4. So divided by 4, we get 1 over 4 right here. And then put a plus c. And that's it. Alright, for number 7. This is 4x squared. Weird. I will tell you what the answer is first before I show you guys some work. This right here, we actually look at this as parentheses 2x and then to the second power, and u will be 2x. So the answer is 1/2 inverse tangent of the input was 2x, like so. And put on a plus c. And again, the input is 2x. So the derivative is the 2. We divide it by that. So that will be it. And just to make this super clear for you guys, let me write that down. This right here, we have to look at this as integral of 1 over 1 plus parentheses square and then dx. So the 4 actually has to go inside. That will give us the 2 and then the x. So the u is actually 2x. Alright, next. This right here is also a little bit slightly more number involved, but it's also not so bad. Check this out. The derivative of 2x plus 9 is just a 2, so we will have to divide it by 2, right? So keep that in mind. But we have to integrate this to the third power. So that will give us, well, let me just write down the inside, which is 2x plus 9, add 1 to the power, we get 4, divided by 4, which is 1 over 4 here. But we have to divide it by 2 as well, right? So let me just show you guys both steps. Right, we integrate u to the third power, we get u to the fourth divided by 4 like this, and the u is 2x plus 9. But the derivative of u is 2, so we divide it by 2. So we do it like that. But of course, we should multiply that out, so I'll write down 1 over 8, 2x plus 9 to the fourth power, and then plus c. That will do it. Number 9, pi x. Alright, I'll write down the answer for you guys first. 1 over ln pi, and then multiply by pi to the x power plus c. There's actually a very nice formula you can just remember. Whenever we have a base b to the x power, you get b to the x, but if you're doing the antiderivative, if you're doing the integral, you divide it by ln of the base. So that will do it for that. Lastly, this will be our u, and the derivative of u will be 1/2. So when we divide it by that, will be a 2. Integrating secant square, we get tangent, and then the inside stays the same. But divided by 1/2, we multiply by 2, and then put on a plus c, just like that. All right. So that will be pretty much it. And perhaps before we go, I will show you guys a little proof for this right here. The deal is that when we have the pi to the x power, we are going to look at that as e to the ln pi power, because we like to differentiate and also integrate anything with base e, not base pi. And this is okay because e and ln cancel, we just still have the pi. And then we raise this to the x power, so we can just multiply this by x, like that, and the dx. So when we integrate this, it repeats, which is still pi to the x power, but the derivative of x times ln pi is ln pi, so we have to divide it by that, just like what we did over there. So you must be comfortable of doing this kind of questions in your head, and yeah, otherwise calculus 2 is going to be just really long. So you guys can follow me on Instagram because I'll post some like derivative and integration notes over there, and you guys can check out my other videos for other parts. If you need more help, if you have any questions, leave a comment down below and let me know. So as always, that's it.